Okay, folks, here we go again with some new marvelous stuff for Algebra 2, Section 7.3, beginning on page 300 for those who like to follow along the book, and it's always a good idea to do so. First of all, let me mention, I've lost track of who I have and have not done this with so far. I don't know if you guys have had any quizzes yet embedded in the videos, but in case I haven't, I'm going to be embedding little simple 4 or sometimes 2 question quizzes in the videos, just as a check to be sure that you're actually watching the videos. Just a reminder, in case I haven't told you before, when you respond to the quiz questions, I want you to send me one quick email, no attachments, no photographs, no pics, no nothing, no attachments. Just an email with the subject line, Algebra 2A or Algebra 2B. Please don't forget the A or the B designation. And then quiz, in this case, 7.3. So put that in your subject line, and then in the body of your email, just type in, please, into the body, the answers to the 4 quiz questions. Tell you what, let's start with one right now. Where should the answers be? They should be in the body of the email. So the answer to question number 1 is body. Done. And we'll soon have question number 2. We move on. What's the square root of 16 ninths? Well, what number when multiplied by itself gives 16 ninths? If you remember your basic arithmetic from about 2nd, 3rd, 4th grade, you'll realize that 4 thirds times 4 thirds is 16 ninths. So there you have it. Let's look at this guy. What's the square root of 16? 4, What's the square root of 9? Yep, 3. What do you get? Same thing. There's a moral to that brief story. That means that the kth root, meaning any root, whether it's square root, 3rd root, 4th root, I don't care, the kth root of A over B will be equal to the kth root of A over the kth root of B. In other words, you can take this guy and you can split it. You can take this guy and you can split it into 2 separate radicals. Or the other way around. There will be times when you'll have one that's already a fraction, and as long as the indices are the same, you can combine them under 1 radical. That's going to come in really handy. Moving on to the first example. These examples are coming from pages 300 through whatever, through page 302. So this is the next example in the book. The idea here is that you can simply think of it as a cubed root of 27 over the cubed root of 125. Well, the cubed root of 27 is 3, and the cubed root of 125 is 5. Done. So I did that splitting it into 2 separate radicals thing in my head. No big deal. Likewise here. Oh, be careful with this one. See something you have to watch out for here? Square root of 25 is 5. Square root of y squared is y. What mistake did I just make? Oh, I know. Yes? You forgot the absolute value. Oh, did I actually forget? Don't insult me, imaginary student. I didn't forget. I left it out on purpose. Oh, I'm sorry, Mr. Fair. That's all right. So, yes, we need to have the absolute value of y because I'm taking an even root of y squared. I get the absolute value of y. If you have no idea why that has to be there, go back to, back a couple of videos. Where was that introduced? Was that section 7.1 or 7.2? I don't even remember now. But I think it's section 7.1. Go back and review that video to find out why that's necessary. I'm not going to review it here. You have the power to rewind me and go back to the past. Kind of cool. This guy, well, more of the same. I can think of this simply as a square root. I use the word simply a lot, don't I? I'm sorry. I guess I'm never going to get over that. We get the square root of 16x cubed over the square root of y to the 4th, and we play with that a little bit. Square root of 16x to the 3rd, well, we know the square root of 16. That pa-chings out. But square root of x cubed, remember the trick here. Think of that x cubed as being x squared times x. We know the square root of x squared, pa-ching, it pops out. We don't know the square root of x, it stays inside. Do I need absolute value this time? You better believe it, because I'm taking an even root, so I need the absolute value of the x out there. Sorry I'm writing so small. I think sometimes in these videos it's hard to see the things that are written too small. Good thing I normally write big. So what happens here? Square root of x to the fourth? Yeah, you know this. Oh, that's a y, sorry. There. Square root of y to the fourth? Yeah, you do indeed know the story of that. It becomes y to the second because y squared times y squared is y to the fourth. This time, do I need the absolute value? No! Ah, you're right. No, you don't, because y squared is already positive. If it's already positive, why would I need to make it positive again? I don't need to. All right, we move on. Oh, let's extend. Okay. Cubed root. Okay. Well, we can think of this as, and I'm just going to go ahead and write it this way. We can think of it as cubed root of 27y to the fifth, that's a 2, over the cubed root of 343x to the third. Well, this one's kind of nice because we know a lot of stuff here. We know, for instance, the cubed root of 27 is 3. And of that y to the fifth, let's think of it this way. We can take out multiples of 3. Out of the y to the fifth, in your mind you see y to the third times y to the second. The y to the third we can take out. Yes, you can take out any multiples of 3. So we can take out a y to the third, and what's the cube root of y to the third? It is y. And we're left inside with the cube root of, what was left inside? I took out y to the third, so I'm left with y squared. By the way, a common mistake I see on tests, folks who get a little carried away, they're so pleased with themselves that they know what they're doing, which is a good thing, but in their haste, they forget the index. If you forget the index, I'm sorry, I've got to take points off. Don't forget the index. Without the index, you've changed the meaning of the whole thing. All right. Do I need this in absolute value? No, not with an odd index. You do not use absolute value. Over what? All right, finishing up here. It turns out the cubed root of 343 happens to be exactly 7. How about that? Who would have thunk it? On a test, I would not give you something like the cubed root of 343 because I do not expect everyone to just know that 7 times 7 times 7 is 343. Who knows that? So I would not give you that on a test. I'd make it easier, like 125 or 27 or 8. Those are easy to take the cubed root of. And likewise, it's easy to take the cubed root of x cubed. That's just x. Do I need absolute value? No! Odd index, right. We're done. We move on to the next example. There are 2 ways to handle this one. Let's look at it both ways and make sure we get the same answer both times. One way, let's just simplify the numerator. Is there a square that goes into 80? You know, there are some of these that you need to learn to, with experience you will, learn to see them quickly. Like you should know, for instance, that the square root of 8 is 2 square root of 2 without having to think about it much. You should know that the cubed root of 27 is 3 without having to think about it much. You should even get used to the idea that the fourth root of 81 is also 3 without having to think about it very much. And you need to recognize that 80 can indeed be factored into 16 times 5. So we think of that 80 as a 16 times 5. Why? Because we know the square root of 16, it chings out, becomes a 4. And here we have square root of 5. All right, copy this, square root of 5, still down there. Oh, but wait a minute. Can I cancel the square root of 5 over the square root of 5? Sure can. Bang, gone. Your answer, 4. Done. That's one way to do it. The other way is this. Forget about the 16 times 5 stuff here. Let's repair that. Okay. Let's go ahead and combine it as 80 over 5, which happens to be square root of 16, which is 4. So there are times, depending on the numbers, depending on the problem, there are times when it's easier to simplify this first and then see what happens. There are other times when it's easier to divide this first and then see what happens. In this case, it's kind of a toss-up. Which way is easier? They're both pretty easy. It's up to you. But you need to consider that there are two ways, and sometimes this method will be easier. Sometimes the simplify it first method will be easier. Depends on the circumstances. Let's go on to the next example from the book. Okay, this guy, my note here, use whichever way looks easiest to you. In this case, to me, it looks far easier to combine this as 5 cubed root of 32 over 2. Why am I allowed to do that? That radical sign is horrible, but that's okay. 32 over 2, I can do it because they are both cubed. Whoa, what's that 3 doing out there? Sorry. They are both cubed roots. Because they are both cubed roots, I can combine them under a single radical, which becomes 5 times the cubed root of 16. Now we just simplify the cubed root of 16. Well, what cube goes evenly into 16? 5 cubed root of 16. Ooh, how about 8 times 2? Because we know the cube root of 8. Cube root of 8 is 2. Pa-ching! Pops out. Oh, don't forget, multiply that new pa-ching 2 by the old 5. And inside we're stuck with this poor 2. You can't come out. 10 cube root of 2. We're done. And we move on to this one. Ooh, what a beautiful example. We're going to combine it as a single radical because that makes this one a whole lot easier to deal with. We have 32, a to the 5th, b to the 3rd. Downstairs we have a 2, but wait a moment. That b to the negative 1, what does a negative exponent say? Remember, negative exponents whisper to you. If you get close, you can hear it. Move me to the other side. Yes, it wants to be moved to the other side. Negative exponents are very unhappy. That b to the negative 1 is saying, I want to be on the other side. So you go ahead and make it happy. You put it on the other side. So we move the b to the negative 1. Up here it becomes b to the positive 1. Now it's happy. So what's this all become? A lot of this work you would do in your head, okay? But I'm just doing it all in glorious detail here so you don't miss anything. So now we have, oh, look at this, 32 over 2. Cool. We get 16, a to the 5th, b to the 4th, and we're practically done. What's the 4th root of 16? Do you know? That's another one that I expect you to get used to. 4th root of 16, 2 times 2 is 4. Times 2 is 8. Times 2 again is 16. Yes. 2 to the 4th is 16. So the 4th root of 16 is 2. What about this a to the 5th? Remember the trick here. We can take out any multiples of 4. I can take out a to the 4th. But if I take the 4th root of a to the 4th, it becomes pa-ching, a. And I'm going to be left inside with one lonely a that got left behind. But wait a moment. Haha, yes. Even index. I need absolute value. And then we have the 4th root of b to the 4th. Oh, well that's easy. 4th root of b to the 4th is just b. Also in absolute value, but can we just combine them under a single AB, absolute value AB like that? Yes, we can. That's a whole lot nicer looking than that. Okay, so yeah, put them under one absolute value sign. So we're done. It's over. Now what's next? Oh, now it gets really fun. Now consider something from the distant past, something to learn back in pre-algebra. What is 6x plus 4x? Yes, we get, of course, 10x, right? Right. Now, what if, however, instead of having 6x plus 4x, what if I have 6 bananas plus 4 bananas? I would have 10 bananas, last time I checked. They don't change into plantains just because I'm adding them. 6 bananas plus 4 bananas would be 10 bananas. Right. What if that x happens to be a square root of 7 instead? Does the rule change? No, the rule doesn't change. 6 of these guys plus 4 more of those same guys gives me what? It gives me 10 of those guys, whether they are bananas or X's or whatever. 6 of these guys plus 4 of these guys gives you 10 of these guys. You can do that as long as we have like radicals. Just like here, you can do it as long as you have like variables. Here you can do it as long as you have like radicals. No problem, right? Right. Anything else down here? Nope. Next page. Now in this case, oh, this is another reason. That's, the tricky one doesn't come till later. I've got 8 cubed roots of 2 minus 7x cubed roots of 2 plus 5 cubed roots of 2. Well, that means I must have 8 minus 7x plus 5 cubed roots of 2. What dastardly mistake did I just make? Did you need parentheses? Of course I needed parentheses because the way it's written right now, I'm only multiplying the cubed root of 2 by 5. These guys are left out in the cold. No, I had to multiply the whole thing by cubed root of 2. Now, by the way, I can simplify this. I've got 8 plus 5 being 13. And I can now write 13 minus 7x. Of course, I cannot combine those. They're not like terms. Times the cubed root of 2. We're done. We're done. If you can't add them, don't add them. But certainly, they must be in parentheses. That's not optional. This next example here. Let's see, what have we got going this time? We've got 6 fifth root of 4x plus 4 more fifth root of 4x. That would be 10 fifth root of 4x. But then we're going to subtract the third root of 4x. Guess what, folks? These are not like radicals. Fifth roots and third roots, you cannot put those together. Don't even think about it. You're done. Oh, so what do we do next? Nothing. You mean we're done? Yes, we're done. Oh, we're done. Okay, so what happens next? Nothing. Oh, okay. You mean we move on? Yes, we move on. Okay. Are these like radicals? No, they're not. But wait just a moment. Maybe they are like radicals in disguise. What do you mean by that? Well, the 8, usually in our head, the 8 turns into 2 times 4. The 4 pa-chings out. Pa-ching! Turns into a 2. Pa-ching! 2 times the old 3. And I'm left inside with that 2 that can't pa-ching because he's not a square. Minus 5. Oh, look, they actually are like terms. That's what I meant by they are actually like terms in disguise. You have to simplify this guy first. And now what do we have? We have 6 of these guys minus 5 of those guys leaves us with 1 of those guys. Please, exercise mathematical maturity. Mathematical immaturity puts a 1 out here. Oh, folks, come on. What's 1 times the square root of 2? Square root of 2. Don't put a 1 in front of that. That's mathematically immature. You know better than that. You've been doing this for a long time. All right. And let's see, this guy. Oh, these are not like radicals. Can I simplify? I can't sit. What do we do with that? Nothing. Haha, they're tricking you. In fact, if you don't believe it, you can look at example 12 on page 302, and the answer is it's already simplified. There's nothing wrong with it. It's just you can't simplify it because it's already simplified. You're done. They are not like radicals. They cannot be simplified. You can't make them into like radicals. You're done. You're done before you start. On a problem like this, I do expect you to copy the problem and then tell me that it is done, because otherwise, if you just leave it blank, I assume you skipped it. Or if you just leave it like that, oops, what happened? Oh, wrong button. If you just leave it like that, then I think that you also didn't know what you were doing. I think you left it blank. So tell me someplace that it is done if you see any like that. I don't even remember if there are any like that on the assignment. All right, and the last guy. I think this, yes, it's the last one. Yeah. Okay, getting tricky on us this time. Let's, in our head, change that 16. That's not in your head? I know. Change that 16 into 2 times 8. Why? Because I know the cubed root of 8. So if I paching out the 8, cubed root of 8 is paching 2 times the old 5, 10, cubed root of, the 2 is left behind. But wait a minute, I can take out any multiples of 3. I can take y to the third out of this. Cool. Paching! Y to the third comes out. No absolute value, it's an odd index. And I'm left with a y. Nothing to simplify. Oh, look. Now, they didn't look like they were going to be like radicals, but now we see they are like radicals. Cubed root of 2y, cubed root of 2y. That gives me, therefore, 10y plus 7. 10y plus 7 in parentheses, cubed root of 2y. We're done. Meditate on that for a while. We cannot add 10y plus 7, so we have to write it as 10y plus 7 in parentheses. Why parentheses? Because without the parentheses, then I'm only multiplying this by 7. And the 10y is out there by itself crying, no, you must include the 10y. So the whole thing is multiplied by cubed root of 2y. And we're done. So that brings us to the assignment. Your assignment will be on page 303. Page 303, numbers. And I did not write down what the assignment was going to be. I've got to go back to my old plan book from last year and see what I gave last year, which I'm sure is still good today. Last year I gave page 303, numbers 2 through 46 even. Okay, so again, as I mentioned in the previous video, now that we are having class officially only on Mondays, Wednesdays, and Fridays, you'll be seeing this on a Wednesday, which from your perspective is today, but from my perspective is tomorrow, which is really a weird thought when I think about that too much. And therefore, this assignment being given on a Wednesday, it'll be due on Friday. So this is due on Friday, April, whatever, the first Friday of April, just a few days from now. Well, from your perspective, 2 days from now. From my perspective, 3 days from now. Oh, that's so weird. Okay, and we're done. So enjoy. Be sure to... Oh, wait a minute. How many quiz questions did I give you? Oh, no. I only gave you 1 quiz question. We can't have that. I have to give you a second quiz question, so we'll have at least 2 points for the quiz. So your second quiz question will be, what is the square root of x squared? Now, this quiz question actually does check you for comprehension a little bit, because remember the trick. Even index, don't mess it up. Get it right, or you're going to lose 1 out of 2 points on this quiz. So question number 2, last quiz question, what's the square root of x squared? Quiz question number 2, and last for this video. Be sure to send me that right away, don't forget. Email it to me, the 2 quiz questions. Do not forget. Goodbye. What am I doing? I don't know. Walking over here to turn you off. That sounds so cruel, turning you off. Take that.